Bismillahirrahmanirrahim. Friends, I'm Mir Muhammad Wasik on your channel Mir's Electro World. Well, fellows, today we are going to see what exactly the force is. And we will see this one factor on which Sir Isaac Newton was working and came up with three laws of motion. And we will see the connection of force and the three laws of motion today in this video. Now, according to Newton's first law of motion, Now, Newton's first law of motion is saying that any object that's in motion, right, or any object that's stay in one place will not change. Either it's stationary or it's in a moving, you can say in moving mode, right? It will not change its state until an unbalanced force is applied on that object. We call it Newton's first law of motion. When Sir Isaac Newton was working on this first law of motion, then he come to the conclusion that if an object that's stationary, what are the factors required to make this stationary object in motion? So basically, that was you can say something that came in the mind of this genius scientist, right? Even people are saying, like, when we are saying about the laws of motion, the people are saying, well, if Newton is saying it's obvious and common that we all know, like, force is equal to mass into acceleration. It's not very simple like it, right? Why force is not equal to mass into the velocity? Why it's not equal to mass into the speed? Why it's equal to mass into the acceleration? This is the, you can say that's what this, you can say this genius mind, Sir Isaac Newton, is basically telling us. While pondering when he was working on first law of motion, right, the stationary object, he was pondering what are the factors that are required to make this stationary object in motion. Okay? So here comes the force, and the force, definition of the force is second law of motion. Now the second law of motion is saying second law of motion is strictly defining this factor here that Sir Isaac Newton was pondering. This is the force. Now he calculated that force is equals to mass into acceleration. It's not very simple. It's not simple. Because why it's not equal to mass into the speed, or why it's not equal to mass into the velocity? Why it's equal to mass into acceleration? If you understand it, you can understand the difference between force and momentum also. Let's have a look. What is momentum? Momentum is P is equals to mv. Now this is mass into velocity, right? Now, have a look. Just solve it. The force is equals to mass into acceleration means rate of change of velocity. The rate of change of velocity is called acceleration. So what I'm doing is I'm placing this thing here, the rate of change of velocity instead of this acceleration. And what I get is, what is this? This is basically force is equals to mv is the momentum. Momentum in time, so it means it's not just momentum. We need changing momentum in time. Changing momentum in time is equals to force. It's another definition of it. And if you understand it, you can clearly distinguish between momentum, right? Momentum and force. That's what you can get, right? So this factor brings the second law of motion. Now, how Sir Isaac Newton come up to the third law of motion? There is also a connection of the same, this factor, we call it force. He was pondering about the moving stars, right? Planetary motions. And he was pondering about the factors that need to make motion in a star, or if a star is not moving. So that's the reason he come up with these three laws of motion, and these laws are so accurate that we can easily use these laws to even calculate the motion of the celestial bodies, right? Now the third law, what is the connection of this force with the third law? We will see it. Now the third law of motion is saying, third law of motion. Now the third law of motion is saying every action has an equal and opposite reaction. So it means if I'm applying a force in one direction, I'll receive a counter force in the opposite direction. Again, the force is here. So because Newton was pondering about this factor, that is bringing a stationary object into the motion and come up with the second law of motion, and after that, what he had done, he applied this force and he checked the consequences of it. Now, when you are applying the force, right? When you're striking a ball with a ball, what happens? You are applying a force, right? This is the force you're applying, and now the ball is striking with this any sort of a wall, right? And it comes back, right, in the opposite direction. So here, this is the implementation of basically, now when you are implementing the force to make an object, or if you are trying to, you can say, apply it, when you're applying it, you're experiencing an opposite and equal reaction to it. That is Newton's third law of motion. So in this way, Sir Isaac Newton came up with these three laws of motion that we use to calculate, even not on the Earth, you can easily calculate motion of the objects, right? Even in the space, right, in the celestial bodies, you can deploy these equations. So hope so, gentlemen, today in this video you can understand what exactly the force is, what is the relationship between the force and the momentum, right? And the changing momentum is also force. It's another definition of the force. Force is equal to mass into acceleration. Now this changing momentum is proven, right? Changing momentum is also the force, not momentum. Momentum is not force. Changing momentum with time is force, gentlemen. Hope so you understand the three laws of motion and how Sir Isaac Newton come up with the different three laws of motion. And gentlemen, if you like this video, please subscribe my channel and share my videos with your friends. And thank you. Thanks for watching.